For the rest of the semester, we are going to be basically going through Earth history, starting with the formation of the Earth and walking through time to today and seeing how both the physical planet has changed over time and how life on our planet has changed over time. And one of the tools we use quite a bit to represent the geology and also the past geology are different kinds of maps. And just so you'll be familiar with the kind of maps you'll be seeing in the lectures going forward, I wanted to introduce you to those today. So we have geologic maps. And these are very colorful, and they show the distribution of different rock types, basically the formations of rocks, the ages of those, and structures you can have in a region. And we see that on this little snippet of a geologic map right here. Notice there's different colors. Each one of those different colors corresponds to a specific rock formation. You'll also see these letters that are in there, like this says PL. Well, P in that case stands for Permian, and then the L is whatever the name of that formation is. It starts with an L. Here you see QTA, that means Quaternary and Tertiary Alluvium. That just means it's dirt. Here we see J. J stands for Jurassic. There's another Jurassic unit. So the different colors and then these symbols tell you which rock formation you're dealing with. The dark lines are the contacts between the formations, where the two rock formations meet. But then you also see this like toothy thing right there. That is a symbol for a fault, specifically a thrust fault. So really on these geologic maps, oh, and we also see strike and dip symbols. Like that says this rock is dipping 86 degrees, so it's almost dipping vertically into the ground. Over here we see that rock is dipping 25 degrees. And so you'll see on these geologic maps symbols for the rock formations, symbols for structures, and it also will always give you the age of those rocks. So anytime you're dealing with any geologic maps, make sure to look very carefully for all those little details on there, because the age, the structures, the rock type, and so on are all done through the different colors and symbols on the map. And so these maps are not the sort of thing you can just glance at and be done with. You want to look at the details. Now the neat thing with modern geologic maps is the colors. They're color-coded. The United States Geological Survey has standard colors used for the Paleozoic, the Mesozoic, the Cenozoic, and so on. So usually when you see colors like these sorts of purples and reds and so on, we're dealing with the Paleozoic. When you have greens, you're dealing with the Mesozoic. And when you have yellows and browns, you're dealing with the Cenozoic. And then what you can do with these geologic maps, you can take all the information of the strike and the dip and the structures and the faults, and you can get what's called a cross-section, one of those geologic cross-sections where we slice the earth, look at it on its side, and then we can see what's going on underground. Like we can see all of these rocks are tilted into the direction of the east right there, right? They're all tilted downwards. And on there we can have our faults marked and our different rock formations. So these geologic maps can give us lots of information. And a little bit later on in the semester, you're going to have a lab where you look at different geologic maps and interpret the history from them. Now, another very common map that you're going to see, that we're going to use a lot in this class, are paleogeographic maps. And this shows the geography of a specific time period in the past. And how do we do this? Well, we look at the different rock types and interpret what they mean. And we can put together this paleogeographic map. This particular one is of the late Jurassic. And what we're seeing, the modern state borders are superimposed on there. So we have New Mexico, Arizona, Colorado, Utah, Nevada, and then this is California. You can see a lot of California didn't exist then. And so what we've done is we look at, oh, we have fluvial rocks in this part of Arizona, so we know there was a river system there, and in Utah. We have a whole lot of aeolian sandstones in this part of New Mexico and Colorado, so we interpret that there was a desert there. And so using these interpretations from rocks, we can put together an idea of what the geography at this particular time period looked like. Now, another map that is not, we don't use it as often, but it can be important for certain types of studies, is what's called an Isopack map. Anytime you see ISO in science, ISO means equal. And an Isopack map maps the equal thickness of a specific rock formation. And so this shows your changes in thickness of either a lithostratigraphic unit or a chronostratigraphic unit. So you can either do the rock formation or the time formation. And what we can do with this, why it can be important, it can show us, for example, the source area of something, because sediments are usually thicker closer to their source and they get thinner away from their source. Or, for example, this map right here, this is part of New Zealand on the North Island. There's this lake here called Lake Taupo, and this is a caldera where there was a very large volcanic eruption in the past. And what we've mapped out here in the isopacks are the thickness of the ash from that eruption. So we can see the ash was thickest right here. We have 500 centimeters, actually, I think, yeah. And then we have 200 and 100 and so on. And what this shows us in this case, since we had this volcanic eruption and the ash was carried, it shows us the prevailing wind that was there at the time of the eruption. It blew all the ash in that direction. So those are Isopack maps, maps of equal thickness. We don't use those as often in this class, but you'll probably see a couple of them when we're doing certain analyses. Another common map you'll see in this class are Lithofaces maps. And this shows the extent of the different facies of rock units. Remember, for instance, when you're along a coastline, you have right along the shoreline a sandstone facies, and then when you get a little deeper, it's the shale facies, a little deeper, it's limestone. Well, these sorts of maps can help when we're doing those paleogeographic interpretations. They can help us figure out like water depth and so on. And so, for example, here's a Lithofaces map where we have, for instance, our carbonate rocks out here. We have shale mixed with some limestone here. We have shale mixed with sandstone here. We have sandstone and conglomerate. And when we see this change in facies like that, that helps us put together that our sediment source area was out here, right? That's the biggest clasts, the biggest pieces will be closest to the source area. And that tells us we must have had some a shallow sea out here if we have carbonates like limestones. So we're going kind of from a mountainous area to a shallow sea over here. And by mapping out those lithofaces, that helps us come up with that interpretation. And so those are some of the types of maps that you'll be seeing throughout the semester. And that's your random picture with this. That's just another day in the field when I used to do a lot of field work.